don't need to be here, I think. So I was going to tell you all about how we did syncing, and I just spent 7.5 months of my life, and maybe I didn't even need to. I could have just waited. I could have just been doing nothing that whole time and waited for CloudKit. I can't believe it. I think I'll be a footnote in history, right? The last guy to write his own custom syncing solution. I'll always be remembered for that one thing. Thing is, though, I don't actually know if we don't have enough details to know if CloudKit will do what we need for Vesper syncing. Maybe it will, and maybe it won't. And if I was watching the State of the Union right now, I might know more. But nah, we're here. We're being indie. It's cool. So yeah, I just don't know about it. See if this thing works. Right, the real title screen. My talk is all about how we did syncing. So the first step in doing any kind of syncing solution I discovered on my own is to write about it incessantly. And so that's what I did on my blog. I wrote a series of posts called Vesper Sync Diaries. We weren't at all secretive about the fact that, that we were working on syncing. We knew, obviously, we must have been working on syncing, right? So we told the world. And then as I was working on it, I didn't necessarily have all the details in place, so of all the architecture and everything. And so I needed to work all that stuff out. And the best way to do that, for me anyway, is to write. And I realized I could also publish at the same time. You know, there's no reason not to do that. And so then I got a lot of feedback from people, and that really helped. Made in the end for a much better app for syncing that works really, really well. Of course, when Vesper 1.0 shipped and we had no syncing, we knew we were going to add it, but we, or at least I, was a little surprised by the sheer amount of people who said, we need syncing right now. And I'm thinking, well, why? It's just an iPhone app. What are you going to sync to? But it turned out that people cared an awful lot about having a cloud-based backup. It wasn't just the idea of having it in multiple places. They really, really wanted that cloud-based backup. So the word syncing, turns out, has a lot of different meanings to different people. But we just use the one big term, syncing. But having that backup is huge. So we realized we didn't have to do a Mac version or an iPad version along with shipping syncing. We could just ship that for iPhone alone, and it would still be valuable for a lot of people. And of course, when I talk about syncing, I usually refer to your day phone and night phone, right? Because everybody has one of each, right? So we had to figure out what we were actually going to use for our syncing system. And there was no such thing as CloudKit 7.5 months ago, but there was iCloud. And iCloud has one thing that is really, really cool. Two things. One, it's free. The other thing is there's never a need to create an account. If the user has an iCloud account, you don't have to create your own accounts system, right? It just works magically, wonderfully. But we realized iCloud wasn't going to work for us because iCloud was not cross-platform in any way. And we might want to do a web version. I doubt we'll ever do an Android version, but we don't want to say that we never would. We might. We didn't want to be limited. iCloud is completely limited in that way. I don't know if that changes with CloudKit. We'll have to see. I hope so. Another thing we looked at was Dropbox. Dropbox not only has file-based syncing a folder of files, it has something called the Datastore API, which is basically database syncing. And it's pretty cool, except it had a bunch of limitations. I don't remember exactly what they were. They were file sizes or amounts of data or something. Another big limitation was that it meant our users would all have to have a Dropbox account. And we couldn't necessarily count on that. And it would have been kind of not nice of us to make everybody get a Dropbox account just to get their notes syncing. So we decided not to do that. Also thought about just doing like a straight file storage-based system, where we put everything up on S3 or use WebDAV. Omni does that, and does that very well with omnipresence, their thing. But I decided that would just be really, really hard. It's really nice to have a smart server on the other end that, that understands the data and can do very efficient and fast things. And just writing the files seemed like a recipe for, recipe for not working. So in the end, we decided to go with Node.js, which is a JavaScript server, and it's a lot like writing Objective-C apps in some ways. I mean, we all use blocks these days. And what Node.js is it's basically writing a server using blocks. So you have asynchronous things happening, like calls to the database and everything. And you've got just like we're used to. And I liked that model, and I liked how fast Node is. And so we decided to go with that. Another great part of Node is the Node Package Manager, abbreviated as NPM. There are wonderful packages out there, so many of them, and the package manager itself is a very nice, easy-to-use piece of software. So using other people's code is pretty simple to do in Node, so we could leverage a lot of great stuff. Then looked at where we might put our Node.js server, and there are a bunch of places like Joyent, Nodejitsu, and stuff that do like Node.js hosting for you. But the one I ended up liking the best was Azure Mobile Services. And partly that's because they came to me without even knowing that I was going to be working on this, and showed it off to me. And so we had a relationship with them. But it goes beyond just that relationship. They offer a number of kind of like training wheels, basically, for a person like me just getting back into server-side programming after 10 years. So it's a very nice, easy on-ramp, but then you're not locked into something that can't grow with you. It is easy to get on, but also still very, very broad. And it composes with other Azure services, too. So you're not like stuck into something. So the big question that people keep asking is about the economics of syncing. Now, going back to iCloud, if that's free, then great. If we could have been able to use that, then that would have been wonderful, and we never would have had to worry about money. But as it is now, we have to pay for server costs, bandwidth, storage, and all that kind of stuff. And so that's a real question. The best thing we could do was try and figure out typical usage, what resources that would take, and then I just threw the pricing calculators and tried to figure out how much that would cost us in a year, and then figure out per user what that cost would be. And once I realized that that was really quite low, then I knew, hey, we can make syncing free. And I was really happy about that because it's nice to get recurring revenue for recurring costs, but it's also a pain too, because now we have to deal with in-app purchasing and subscriptions, and it's a headache for support and all that kind of stuff. Way better just to make it free, if possible. And we decided that we could. So I could be wrong, though. I could find that my calculations and estimates were all incorrect, and that it costs a lot more than I thought it would cost. So we do have plans to do things that would lower our costs. For instance, the number of API calls per month or whatever is one of the things we get charged for. And we could do simple things like consolidate some of the API calls into one thing. Like we could sync your notes and your tags with one call instead of separate calls, and thereby cutting down costs. Other things we could do, switching from a SQL database to NoSQL table storage. It turns out NoSQL is just a whole lot cheaper. Now, I generally prefer a SQL database because I like how plastic, how moldable it is, how flexible a SQL database is. But we can make that change without too much trouble, and that would lower costs as well. And finally, if we had to, we could switch to hosting our Node system ourselves. We could get like a $5 virtual machine from DigitalOcean or something, and that would save us, I don't know, $100 a month or something like that. So I don't think I'm ever going to have to do any of this stuff to lower costs, but it's good to have a plan, I figure. So another big issue these days, of course, is security. And what we ended up doing is encrypting your notes on the server side. And so there's a key that the server has that encrypts the note text. And that key is not stored in the code or in the database. Otherwise, it's in a separate, secure storage. What I really would have liked would be to encrypt everything on the client side so that the server never has, so that there's no way on the server to decrypt notes. But I couldn't come up with a good way of doing that that wasn't also a giant user interface headache. Because basically, each person would have to have their own key. And that key would have to be the same on all the devices where they're using the app. And I just, telling people to pick some difficult, random string of letters and numbers and whatever, and doing it the same on every device and never losing it because then they lose all their data, that seemed like a pretty hard sell. Still, though, we continue to look at the issue. I'd love to make it NSA-proof, essentially. So we thought about how we wanted to do our account system. And mobile services has a nice thing where we can use Twitter, Facebook, Google, or Microsoft. And so initially, I think we were thinking of using Twitter and Facebook. But then we ran it by some people who aren't computer programmers, and they were worried that if they logged in with Facebook, that means that Facebook is seeing all their notes, seeing all their data. And there's no way that we don't want to make anybody worry. We don't want to make anyone afraid to put their thoughts in their note-taking app. So we decided to create our own account system. And that wasn't that hard. There's some sample code and everything out there, and we followed standard best practices, got help from the folks at Microsoft. They did a bunch of code reviews and things, and so that's good. It's solid, but it's another thing that takes more time than you think it's going to take. Scaling, of course, is another issue with a syncing system. We don't really know how it's going to perform until we get a whole bunch of people using it. So as I'm developing it, I don't know how well it's going to scale. I have a good idea now, though. So one of the things we did was use blob storage for all photos and attachments. And blob storage is, Azure Blob Storage is basically like Amazon S3. It's just a big, giant bucket of binaries. And as far as I know, that can just scale forever. In our SQL database, we're using separate tables, and those tables don't have any kind of explicit relationships to each other. So we could, if we wanted to, make each table a separate SQL database. So that would help us scale. And if we had to go even farther, we could shard those databases by user. We could end up with 16 or 32 databases. I don't think we'll ever have to do any of those things. I think what we have is going to work for a whole lot of people. But it's good to have a plan. So performance, of course, was a big issue in writing syncing. And so I went with SQL database, as I mentioned. And I have a hard rule, which is that I never use joins, ever. Just because I don't trust myself enough to not screw up performance the moment I start using joins. So there are no joins. And that seemed to work very, very nicely. And again, I got some help from Microsoft folks. I had a SQL Server expert looking over my schema and all that kind of stuff. And that was cool. So one of the keys to making syncing efficient is that we only want to get data that's changed since the last time the client asked for changes. And so it turns out there are really two types of time information you want to store. You want the date at which something changed on the client, but you also want the date when the thing actually got updated on the server. And so then when we're making a query to the syncing server, we're asking about the server modification date rather than the client modification date. And as a bit of a subtle difference, and it can hurt your head a little bit to think about it, but it's an important thing to note. And so along with that, we use a thing called sync tokens. And essentially the way this works is when the client makes a call to the to the syncing server, that server returns a little opaque string. But what that string is an encrypted thing with information, including a date. And then the next time the client calls, it passes back that same token. Then the server can know, oh, you're asking for changes since whatever date is encoded in that sync token. This way, the client doesn't ever have to actually know about the dates at that level. It doesn't have to manually say, I want changes since this given date. It just always passes back the sync token that it got from the last call. So I went around the problem of unique IDs. When you have a distributed system, you can't just use like an auto-incrementing ID, like 1, 2, 3, 4, 5, or whatever. If you have multiple devices, then you might have 2 different nodes. You know, here, node ID 5, and over there, node ID 5 would be different nodes. So you need something else. And for a while, I went with UUIDs. The thing I don't like about them is that they're kind of long. And I really wanted to keep our database use as compact as possible. So then I thought, well, I'll use a random 64-bit integer for our IDs and check for collisions. And then I discovered that JavaScript can express integers accurately up to, I think it's 53 bits. Because I could not believe what I was seeing as JavaScript was like destroying these IDs and my syncing system was completely not working. Well, I learned that lesson. So we're using 53-bit IDs for our IDs and manually checking for collisions. We only have to worry about ID collisions per user, not over the entire system. So it's pretty easy to deal with. I wrote a new data layer for all this. I could use core data, and I recommend core data to everybody, because if I don't, I'll get in trouble. But I wrote the data layer of my dreams. The way I really like to work with data on the client is all model objects are accessed on the main thread, and then all database access happens in a background serial queue, so that I'm never blocking the main thread with hits to SQLite. But at the same time, I have the ease of use of having all my model objects on the main thread and not having to worry about concurrency. It makes for a really nice, simple way of dealing with data, and it's really fast. Now we're working on a Mac version, and the Mac version builds, window appears, and there's nothing in it. But that means all the under-the-hood code is building, right? All the syncing code and everything from the iOS version is shared with the Mac version. And, so that's all there. The only thing I might have to do in that area of the code is handling images is just a little bit different, right? So for instance, generating thumbnails, will take some Mac-specific code. But that won't take much. So writing the Mac version is mostly just a user interface issue and not something more complicated. Unless that is, suddenly I switch over to CloudKit. I wish I had more to say about a great plan for testing. That's actually what I need to do as soon as I get back home. I've written some tests, and so I think testing isn't necessarily super useful in getting a system running, but it's super useful in making sure that you don't turn around and break it. So my rule is I'm not going to make any more changes of any kind to the client or server-side syncing or data code until I've got a crazy amount of tests so that I'm confident that I'm not going to break it. And I don't know how that's all going to work yet, but that's the next thing. I'll probably write it on my blog. I got a great tweet from Rich Siegel, Edit fame, Yojimbo fame, and he asked me, how do you deal with the customer support of people having trouble with syncing, doing things to trying to fix it, but thereby making the problem worse? And I didn't really have a great answer to that. It's to design as much as possible the user interface in your system so that there isn't really a way for users to screw it up. Keep it as simple as possible. That said, there probably will be a way. And that's why we have Dave Wiskus to handle our customer support. He apparently likes people. So By the way, I'm wearing my dad's watch. It's Hamilton from Lancaster, Pennsylvania. He got it on graduating high school. So. And this is the actual recipe for a Vesper. And if you have the app, there's a little credits screen in the app, and so that recipe is printed there too. So if you have our app in your iPhone, you will always know how to make a Vesper. Anyway, I would be happy to answer questions. I can do tap dancing. Got a few minutes.
Hi, I was wondering if you could talk a little bit about your goals for testing. Do you plan to focus more on unit tests or tests through the simulator where you're actually testing, like making a node and saving and adding a tag? Which do you feel is more important to you and why?
So the way I'm thinking about it right now, I think I have two main areas of testing, two main approaches. One is to test like every single little function, make sure all the small, lowest level pieces all work. And that would just be unit testing. For the node stuff, that would be Mocha. And then in Xcode, that's whatever we have, these XC tests, I guess. But I also want to do kind of a higher level version of testing, where I actually like have the thing create an account, create some notes, send them to and from the server, just do all the, actually do against the live server what a regular human might do. So I'll just have to find a way to automate that. A big problem with that is there's a lot of state to set up, right? If I've got like a test account, I probably have to delete that account, recreate it, do all this kind of stuff. But that said, it's just software. It's just probably a boring couple days' work. Oh, go ahead.
Hi. I'm curious why you decided to use date or timestamps instead of just incrementing a revision number for the nodes on the server.
That's a good question. So part of the design for this is that we wanted syncing to match what we thought users would expect. And that is, if you make a change on your day phone and a change on your night phone, I think the user expects the last one that they made in terms of wall clock time, their own time, to be the one that sticks. So if we're actually using a timestamp for that, then we can compare and we'll know. But if we're just incrementing a version number, then we have conflicts, right? Now you're at version 4 in both places. Which one ought to win? Well, now we have to pick at random. We present a conflict to the user with some user interface and stuff. So the server sent, well, the time the change gets to the server isn't necessarily the time that the change was made. Does that make sense? Right, because you can make a change, be on the subway, offline or something, and then have made another change, whatever. But you get my point, right? So you want the actual time that the change was made. But that means another issue is dealing with clock skew, right? Because sometimes your phone's not right. The time on your phone isn't right. So whenever we get a HTTP response back from the server, we look at the date that the server says it currently is, and compare that to the current time on the device, and then we just have we save that difference so that when we're actually saving timestamps in the local database, we apply that difference if necessary. I've considered doing some analytics to see if that ever actually happens, because I don't know. Find out.
Are you working in raw SQLite directly? Over here, sorry.
Yeah.
Are you working in just straight SQLite directly, and then?
So I use SQLite, and there's a nice wrapper called FMDB by Gus Mueller, and I've been using that, I don't know, for about as long as that's existed.
Do you have more than one database, or?
Yeah, so one database for notes and tags and stuff, another database for thumbnails. Okay. And I think that's, just the two.
And how do you handle, like, if the network connection is down and you need to go offline and online, how do you keep all those balls in the air? I
don't think I really do anything special. So if it's time to sync and the phone can't connect to the sync server, well, it just doesn't do it. It just, it'll be time to sync again at some time in the future, and then it'll actually connect. But I don't, for instance, present an error to the user, because they probably know they're offline, and that would just be annoying.
How do you handle the case if you have the day phone and the night phone, and somebody using the day phone deletes a note, but the night phone is offline, and so someone makes an update to a note, and when the night phone then has the opportunity to connect, it's trying to update a deleted note. How did you handle that case?
That's a good question. So that just won't work. Let's see. So there's one specific case. A note on one phone, and you delete it on the other phone. If you're still editing it on that one phone, we undelete it. So in the case where you're talking about, where a note's been deleted, and then the other phone doesn't know that it's been deleted, and you go ahead and make changes and stuff, those will get sent to the server and then discarded, and that phone will end up deleting that note. So yeah, that's one easy way to lose a little data. That's right. Right, but except for the case that that note is actually open in the detail view. In that case, we assume that, well, you probably didn't want to delete it because you're still editing it. That maybe you've changed your mind or something.
Do you actually delete things, or do you flag them for deletion?
We delete them. And that part of that's a peace of mind thing, right? If you're storing your stuff up on a server somewhere and you delete it, I think you really want it gone.
You mentioned that the database access is all happening in the background and your model objects are accessed on the main thread. Are they then effectively disconnected from the data store? So I retrieve a model object, and now a background update comes in and says, say, deletes it or modifies it. Are those properties already sort of accessible at the time that you pull it out of the database?
Right, so if I have a note, model object, on the main thread, and sync comes in the background, and something about that note changes, that main thread model object note will update. It will be different. Maybe the text has changed or the list of tags or whatever, but yeah, all that is updated via this system.
Okay.
On the other hand, then there's CloudKit. So I'm just still, I can't believe waking up this morning and seeing this. I'm like, I don't know. I need to know more details. So could we, number one, did Apple do a good job? Because we don't know sometimes, right? Right, well, so I've heard both. I don't know what the truth is. So if there's a way to do a web app with it, then maybe actually it would, solve our problems. And then we wouldn't even have to run servers, wouldn't have to pay for them. I just don't know. I'm still just like the guy in shock, though, who's, spent 7.5 months working on something to hear that, well,
Okay.
Yeah, all right. We'll see. All right, I think we're done. Thanks, everybody.
Let's take another couple of